Blaise Pascal was born in 1623 and died in 1666. During his short life, he accomplished many things and made many fascinating advancements for the world of mathematics. He is more popular in the realm of philosophy for his book titled Les Pensées, which deals with profound existential questions, such as what does it profit a man to gain the whole world and lose his soul? He approached these hard questions of life in an objective and mathematical manner, rather than from the subjective realm of what Kant called the phenomena. He asked many questions and constantly tested the status quo of his day. Pascal was intrigued by geometry at a very young age and made many important discoveries in the realm of physics. He left a legacy and is widely known for his famous triangle, which led Newton to formulate the binomial theorem. Pascal's triangle is the basis of number theory. Using this basis for numbers, he invented the Pascalian, which was a calculator he designed in order to help his father calculate the taxes that they had to collect. This calculator was very technical and consisted of 5 wheels that needed to be turned in a clockwise motion. This calculator could only be purchased by a small number of very rich people. Pascal also experimented with a barometer to test his theory on variations of air pressure according to altitude. Later on, he wrote a treatise on the equilibrium of liquids. This helped the advancements for hydraulics. This brilliant engineer was beyond his time and was also known for tying his pocket watch to his wrist out of convenience, pun intended. Pascal is also known for his famous wager, which uses probability to determine the winner of a game that is not yet finished. Pascal used this idea of probability in order to rattle his rich gambler friends who, in his opinion, were at the risk of losing their salvation since they were simply gambling their money rather than helping the poor. Now let's look at Pascal's triangle. The first thing we notice is that each number that has 2 numbers above it, which excludes the diagonal line of ones, is equal to the 2 numbers directly above it once they are added. Then, observing the diagonal line that is shaped in the form of a positive correlation, or if this was a graph, we would say that it is skewed to the left, these are counting numbers. For example, the second diagonal line is 1, 2, 3, 4, 5, etc. The third diagonal line consists of triangle numbers. The sequence is 1, 3, 6, 10, 15, 21, etc. The triangular sequence is a pattern of variables that form a triangle. The amount of variable increases every time a row is added to the triangle. The first row would have 1 variable, the second would have 3 variables, the third row would have 6 variables, etc. The fourth row, fourth row, horizontal, is 4, 10, 20, 35, 56, 84. These are tetrahedral numbers, meaning that they are similar to a triangle number, except they are not in the shape of a triangle. The tetrahedra, you could say, is a 3D triangle. It has 4 faces, 6 edges, 4 vertices, and each vertex 3 edges meet. It is therefore more similar to a pyramid. Looking down the pyramid from a bird's eye view, you would be able to identify how many dots are needed on each step of the pyramid as we go down. The first row would simply be 1 dot, the second row would have 4, the third row 10 dots, since they're all being added up, so on and so forth. We can also find patterns within the horizontal line of Pascal's triangle. The sum of each line doubles to the power of 2. For example, 2 squared, or 2 to the power of 2 equals 4. Then 2 cubed, or 2 to the power of 3 equals 8. Then 2 to the power of 4 equals 16, so on and so forth. Now, if we look carefully, we can see even more continuity in this triangle. Notice how all the numbers in the 7th row, except number 1, can all be divided by 7. 7, 21, and 35. According to the horizontal lines, this triangle also shows the power of 11. Beginning by the first row, on the top, we see that 11 to the power of 0 is 1. On the second row, 11 to the power of 1 is 11. On the third row, 11 to the power of 2 is 121. On the third row, 11 to the power of 3 is 1,331, and so forth, just as it is shown on the triangle. Another fascinating thing about this triangle is that it can tell us the square root of a number. To do this, you must take a number from the second row diagonal, added by the number that is located to its right. So in this case, let's take the number 3. Look below it, we see 6. 6 plus 3 equals 9. Therefore, the square root of 9, square root of 3 is 9, and the root of 9 is 3. If you want to continue with this exercise, we can add 6 plus 10 equals 16. Therefore, the square root of 4 is 16, and the root of 16 is 4. I hope that this brief explanation about this triangle and its complexity has helped you to understand how Pascal designed one of the first calculators called the Pascalian in his honor. Pascal also used his mathematical genius for theorems of the cycloid. The cycloid later on helped people like Galileo, Roberval, and his friend Pierre de Fermat with their advancements. During his time, Pascal was an elite in the realm of mathematics and competed with people like Leibniz. It is also said that Pascal even had a 2-day discussion with René Descartes on the idea of voids and vacuums.